Hess's law. Standard 7E says students know how to apply Hess's law to calculate enthalpy change in a chemical reaction. Now there's many ways to calculate enthalpy, and we're going to look at two. Now the first one here is going to be Hess's law. Later on you will use calorimetry to find enthalpy, but there's others. Okay, so in AP Chem you will learn about those, but even here we're going to focus on Hess's law. So what is Hess's law? Hess's law says that if a reaction can be expressed as the sum of two or more independent reactions, then the heat flow for the reaction is equal to the sum of the heat flow for each independent reaction. So what he's talking about is basically, so if you have reaction 1, and reaction 1 has a certain delta H that is associated with it, and then there's another reaction called, let's say, reaction 2, okay, and it has a delta H associated with it, and there's another reaction that is reaction 3, and of course these reactions are related, and it has a delta H of 3 in it, meaning if we add all these reactions together, okay, the total of the reaction, that means basically we're going to do the same thing for the delta H. So this is basically nothing more than delta H of 1 plus delta H of 2 plus delta H of 3. Now what we could do too is also flip, okay, meaning we're going to take one reaction and we flip it to make it go the opposite direction, and if we do that we're going to flip the delta H also. So let's take an example of this. So here's a reaction. We need to find the value for the delta H for the following reaction. Okay, so we have carbon sulfide plus 3 oxygen makes carbon dioxide plus 2 sulfur dioxide. So here are the three reactions that takes place when this happens. Okay, they're all, the first two is exothermic and the last one is endothermic. So we're going to take a look at one of them at a time. So what I do is I look at the first one. Here's, notice you have carbon on the reactant side, but up here there's no carbon. Okay, so I can't use that. But I notice that oxygen is on the reactant side also, and notice that oxygen is also on reactant side. So that means my first equation I'm going to keep just as is. So I'm going to write down carbon plus oxygen makes carbon dioxide gas, and the delta H for that is negative 393.5 kilojoules. So that's the first one, all right? So in the second one, again, I'm looking at sulfur, and notice there's no sulfur up there, so I can't use it. Again, oxygen is on my left-hand side, so it's here again, but I already have oxygen on my left-hand side. But notice that the SO2 is on the right-hand side. It's a product, so which tells me that this reaction is going to be the same. So I'm going to keep it the same. Sulfur plus oxygen gas makes sulfur dioxide gas, and that delta H is negative 296.8 kilojoules. Okay, so I'm done with that one. So now I'm on the third one. Now notice the third one, we have carbon on the product side, reactant side, but notice there's no carbon on the reactant side. We have sulfur on the reactant side, but again, no sulfur on the reactant side. But notice that we have copper sulfide on the product side. Now notice that on the main reaction, carbon sulfide is on the reactant side. So what this means is I'm going to have to take this and I have to flip this, okay, make it go backwards. So what I'm going to have is, instead of basically having carbon plus 2 sulfur, I'm going to flip it the opposite way. And when I do that, this becomes the opposite, which is negative. So here I'm going to have CS2 liquid is going to make copper solid plus 2 sulfur. And again, remember, I took my delta H and I flip it, so now it becomes negative 87.9 kilojoules. Okay? So now what I'm going to do is I have to basically check to see if the right side equals the left side. Okay? Meaning anything that shows up on the left side and on the right side, we can basically get rid of. Okay, and what is it called? It's basically like an intermediate. You use it, you make it, and you use it. All right. So if you look at this, notice that carbon is on the left-hand side, and carbon's also on the right-hand side. So in this case, carbon's going to cancel out. Now the oxygen, notice there's 2 oxygen here, but no oxygen inside. Carbon dioxide is 1 here, but there's none on the other side. Sulfur, notice there's 1 here, but there's 2 here. So I need to have this sulfur, basically go away. But notice there's no sulfur up here. Okay, so what's going to happen is I have to double my amount of sulfur. So what I'm going to do then is I'm going to double the amount of sulfur, which means I have to double the amount of oxygen, which means I have to double the amount of sulfur dioxide, which also means I have to double my kilojoules. So I have to double the whole thing. So now because of that, I can get rid of my 2 sulfur. So my 2 sulfur over here will cancel out the 2 sulfur here. Now the last one is my sulfur dioxide is on the right hand side, but there are no other sulfur dioxide on the left hand side. My copper sulfide is on the left hand side and there's nothing on the right. So what I'm going to do now is I'm going to add this reaction up. So notice on the left hand side I have what? O2. There's 1 here, there's 2 here, that makes it 3O2. There's CS2 here, CS2 liquid mix. On the right hand side, notice I have carbon dioxide gas plus the 2SO2. Okay, now notice this reaction looks just like this reaction. Okay, it's identical, which means I did it right. So now all I have to do is add this up. So here I have negative 393.5. We'll have to multiply this by 2. Okay, so 296 multiplied by 2. So 2 into 8 would be 16. Carry the 1. 12 is 13. Carry the 1. 18 is 19. Carry the 1. 4 makes it 593.6. Okay, so that's the new kilojoules, negative kilojoules. So now all we have to do is add this side together. So we have 5, 6, 11. Okay, 11 and 9 is 20. So here we have 2, and 2 is 5. 5 is 8. 8 is 15. Carry the 1. 10, 19, 27. 7 carry the 2. 2, 5, 5 is 10, so this is 1,000, the delta H is 1,075 kilojoules. So notice that when we add all these steps up, we're adding up the heat of the reaction also. So let's take a look at the next example. Here we have find the delta H for the following reaction. Now this looks a little easier, there's only 2 steps to it. So again, we do the same thing. Notice that PCl5 is on the reactant side, okay? Now we look at the first one, okay? So P4, notice there's no P4. Cl2, notice there's a Cl2, but it's in the product side. So what I'm gonna have to do is I'm gonna flip this first one, okay? So I'm gonna flip this one, okay? Flip. So instead of basically P4 plus 6Cl2, it's going to be flip backwards, which is like that. So it'll be 4 PCl3 flip P4 plus 6Cl2. Now remember, since I flip, this becomes positive. So this is delta H of 2,439 kilojoules. So the second one, notice that PCl5 is on the left-hand side, which is where I want it. So I want to keep it on the left-hand side. Okay. So this is PCl5. There's 4 of it. Makes P4 plus 10 Cl2, and that delta H is going to be 3,438 kilojoules. Now, I'm going to start basically trying to get rid of some things, right? So notice that the PCl3 is on this side, and there's no PCl3 on the other side. Okay, so I made a mistake right here. Notice that the PCl3 should be on the product side, but notice I flipped it to the reactant side, so that's wrong. So because of that, my first equation should be the same. So I'm not going to basically flip the first one, so I'm going to change that first equation so it shows that I did flip it. Okay, so that first equation would be P4 plus 6Cl2 makes 4PCl3. Now the delta H is going to be negative. So now in this case, notice that my PCl4 is going to cancel out there and there. So there's cancel out there and there. My 6 chlorine here, notice there's 6 here and there's 10 here, right? Okay, 6 here, 10 here. So I can take 6 of these out. That leaves me what? 4 of these left, right? Okay. Now also my 4 PCl5, and this is PLCl4. Okay, I mean PLCl3. So I can't do anything with those. So what I'm going to do now is I'm going to add this up. So you know this is 4 PCl5 makes 4 PCl3 makes 4 Cl2. Now I'm going to add this up. So now if I add this up, remember this is a minus, okay? This is an exothermic, so technically I'm subtracting, right? So I'm going to take this up here to make it a little easier. My subtractions, because I don't have my calculator today. So it's 3, 4, 3, 8. So subtract that from that, so that makes it 9. 3, 3 is 0, so this would be 9, carry the 1, this is 3, so this is a 9, and basically I have 999 kilojoules, right? Okay, please check my math if I did right. Now notice that also at the end is, notice that there are 1 coefficient in front of them, but these are 4. So what I have to do is divide this whole thing by 4, so the 4 cancels out here, and because I divide all this by 4, I have to divide this by 4 also. So now the new equation, to be correct, would be PCl5 makes PCl3 plus Cl2. Now this is, let's say it's 1,000, okay? So that's 1,000, that would be basically 250 kilojoules, which is the delta H. So notice that in Hess's law, each individual steps has its own delta H. And all we have to do is either flip it, don't flip it, multiply it, whatever we need to do to get the equation that they want. So if you have any question, make sure you ask in class.